All right. With my millions of followers. Number 1, give the domain range in zeros of the function. Square root of 9 minus 6 squared. Oh no, that's not what we want. Okay, what does domain mean? The x values. So let's figure out what x values would not work for this. Would x equals 3 work? Yeah, because that'd make 9, which should make 9 minus 9 0. Square root of 0, yes, that works. Would x equals 4 work? No, because 9 minus 4 squared is negative, and square root of negative is imaginary. Would x equals negative 3 work? Does that work? Yeah, you square the negative and it comes out as positive 9. So you'd have 9 minus 9, it's 0 again. So yeah, it does work. Would x equals negative 4 work? No. For the same reason 4 doesn't work, it would be 9 minus 16, which is negative. So the x values, I think we graphed this one once, maybe. At 3 and negative 3, it's at 0. What's the value at x equals 0? What would the value be? 9 square root of 9 is 3. So at 0, 3, there's a point. Have we seen that before? It's a semicircle. I think we saw it once, but even if you don't remember what it was, you can just kind of plug stuff in and see. But anything past 3, like 3.1 or whatever, or negative 3.1, makes this negative and imaginary. So there's no x values. So what is the domain then for this graph? All right, x values, so the farthest left it goes, negative 3, the farthest right is positive 3. So x is between negative 3 and positive 3 included. Okay, what is the range of the graph? What are the y values? What's the lowest y value on the graph? 0. What's the highest y value? 3. So the y values run between 0 and 3 inclusive. What are the zeros of the function? What does zeros of the function mean? The x values that make the function equal to 0. So what x values make this function 0? 3 and negative 3. They also happen to be the y-intercepts. I guess I could put plus or minus 3. The zeros of the function on the graph are always the x-intercepts, because the x-intercepts always have a y value, a function value of 0. This is 3, 0. This is negative 3, 0. Okay, number 2, we're supposed to graph. And then find the range in the zeros. I probably should go to graph paper. Come on, baby, let the good times roll. I think we did like 2 or 4 of these or something. You guys remember them? They're called piecewise functions. Remember how we did this? It might have been a couple weeks since we had the break. My word, who's that?
Why is it so low?
Like max volume. everybody's gonna admit it? Okay. Everybody's innocent.
It's you sweating.
He's
Sweating. Ready. Can I check them all?
Check every single one.
Yeah.
Yeah.
It's not mine, I know that, so it was just it's all one here. Typical.
Yes, what if it keeps going off? That's such a distracting or learning experience. Just look at it.
too late, it's already a distraction.
Yeah. She's on her phone.
Okay, so for x values less than -1, we're supposed to graph something. Where is x equals -1 at? It's a vertical line. It's basically this. Do not draw this. It's not part of the answer. I wonder if I can move that. No. Okay, anyways. So everything, when x is less than 1, we're supposed to graph x plus 1. Or in other words, y equals x plus 1. So everything to the left of that. What does y equals x plus 1 look like?
It's a line.
Okay, it's a line. You can use the slope and the y-intercept, or you can make up some x coordinates to plug in. Now, -1 is not supposed to be part of the solution set because we're supposed to go left of -1, but that would maybe be a good starting spot. If I plug in -1 for x, what do I get for y? -1 plus 1. So there's a point of -1, 0. But what am I going to put right there? Why did I put an open circle? Because it's not supposed to equal anything at -1. So that's like the starting point. Or, well, okay. I could plug in x equals -2 and you get -1. Or I can use the slope is up 1 over 1 or down 1 back 1. Anyway, looks like that. It goes forever, so. And then from -1 and on, we're supposed to graph y equals 1 minus x squared, or I guess g of x equals 1 minus x squared. What's the shape of this graph going to look like? Okay, parabola. What's the negative right in front of the x squared do? Flips it upside down. What's the 1 going to do? Right, that would be the same thing as like a +1 over here, a +1 over here, or +1. So it's gonna, okay, if I didn't know all that stuff, I could just plug in, like start plugging in x values and get stuff. But basically, it's an upside down parabola with the vertex up 1. So it's gonna, if I plug in -1, it's a very big circle, I would get -1. Or 0, sorry, if I plug in -1, I would get 0 rather. So they kind of meet up at the same point. That doesn't always happen, but it did happen, so I filled it in. And then over here, there's going to be the mirror point. And then if I plug in like x equals 2, what do I get right here? -4 plus 1. So notice on this one, the negative is not squared, just because the negative is not part of x. You square the x and then you add the negative on. It's kind of an order of operation. So 2, -3 has a point. Would I draw the mirror point over here? No, because I'm just graphing from -1 on.
so what was the next question? Find the range?
So what did range mean?
X.
The y values, yes. So, what's the lowest y value? Negative infinity. What's the highest y value? 1. So how do I say that y values are everything from negative infinity to 1? Or everything below 1?
Y is less than or equal to 1.
Okay, y is less than or equal to 1.
There's one more question. I think it's
Find the zeros of a function. What are the zeros of a function? What x values make the function equal 0? Negative 1 and 1. I guess I could just put plus or minus 1 there. They didn't ask about what would be the domain of the function. All real numbers. Goes forever left, forever right.
okay, back. Done with the graphing for now. So number 3 says f of g of x. Find f of g of x, or sorry, f plus g of x rather. Why don't you guys try A, B, C, and D? Ahead of me.
Okay, so on the B section, or the B question, make sure you subtract both of these. So 2x minus x is 1x, and that's actually a minus 2, kind of like distributive property. And on the C, what kind of problem is that? Well, yeah, more specifically, it's a FOIL problem. So first, outside, inside, last. The outside and inside are both plus 2x squared. They're like terms, so they make a 4x squared, I guess. Okay, there's actually 3 ways to do D. Let's see how many you guys can think of, or hopefully you can think of one way. Huh? Okay, long division. You guys know what that means? Might put up plus 0 there, but that's long division. X goes into x squared. How many times? X times what equals x squared? X. Do x times this. Put it down here. Subtract. Start over. What's another way? Synthetic division. So use the coefficients. What are the coefficients for the numerator? 1, 2, and 0. It's also called a dividend. Dividend, divisor, numerator, denominator. 1, 2, and 0, and you put negative 2 in the box. Anybody know what the third way this could be done? And it doesn't work on every thing. This factors, the top factors, because I can take an x out. I was thinking most of you guys would probably think like synthetic division, because we did a lot of that a couple chapters ago. And x plus 2's cancel out. Okay, I usually don't make you write this last part, but why did I write the last part? Yeah, so basically the function is just like y equals x, but x can't be negative 2. So if we were to graph it, you guys know what the line y equals x looks like? It's like a diagonal, except for, well, I put that in the wrong spot. X can't equal negative 2, so there would be like a hole. Anyway, kind of weird looking. Just a little hole in the graph. All right. We're done with page 166. Did you feel accomplished? Okay, so number 4 is actually kind of the same deal, but it says f of g of x and g of f of x. So why don't you guys give that a shot, see if you remember. Yeah, that's not that much work. Let's simplify it. so for the first one, I put the g function into the f function. By the way, do you guys know the other way of writing this, f of g of x? I kind of prefer this way actually because you can see that the g is going into the f function. But, I mean, the order is the same over here, I guess. So, basically what I did was I took the g function and put it in to both x's on the f function. So this parentheses right here used to be an x in the f function, and this used to be the x. You guys see it? And so the x plus 2 squared is actually a FOIL problem. X squared plus 2x plus 2x plus 4. So it's that. And if I add them all together, simplifies to that. This other one doesn't really. So on the other one I put the f into the g, so I just put all this stuff right there. So it's just x squared plus 2x plus 2. Doesn't really simplify any more than that. Parentheses don't do anything when you're adding. Any questions on that? I don't think we did number 5, but that's okay, we can still do it. Yeah, we didn't make it that far in that assignment. X squared minus xy equals 4. Let's see if I remember all these tricks. So, what do you guys think it means by does it have symmetry in the x-axis? Any ideas on that?
It's symmetrical across the x-axis.
Yes. So in other words, if it looks the same on the top as the bottom, like if it's, so an example would be like if it looks like this, that has symmetry in the x-axis. Does it have symmetry in the y-axis? No, because if you like fold it this way, it looks different. But if you fold it this way, it would be like the same. So if something has symmetry in the x-axis, basically there's kind of a trick. So without even graphing this, if you replace y with negative y, that would make it like a vertical flip. And if the function comes out the same, then the answer is yes. So what does this simplify to right here? What's that simplify to, that term? Plus xy. Okay, is that the same as equals 4? Is that the same as the original? No, so it's not going to have symmetry over the x-axis. So guess how I'm going to tell if it has symmetry over the y-axis? Well, if it has symmetry over the y-axis, it might look something like that. For every positive x value, there's a negative x value that's the same. So if you switch the x values and the function function comes out the same. And it's symmetry, it has symmetry in the y-axis. What's negative x squared simplified to? Minus xy? Is that the same as the original function? Original equation? No. The minus became a plus. So there is no symmetry. Wonder what this graph would look like. Take an x out and get x minus y. Have to manipulate it. I don't want to actually spend enough time to figure it out. Let's keep going. X squared plus xy equals 4. All right. Now with this last one, the third one we've kind of talked about. How do I know if it has symmetry over the line y equals x? Yeah, if you switch the x and y values at the same thing. Okay, are these two the same thing? No, x squared and y squared are different, so no. Okay, about the origin. I think what about the origin means is you switch, I don't remember for sure. I think you switch both the x and the y. Or make both x and y negative, I think basically it's a rotation, but this part maybe not as important. So if I make both x and y opposite, does it come out the same? Yeah, it does. So there is symmetry about the origin. I think it's basically like a 180-degree rotation.
Didn't we start with x squared minus xy or something?
Huh?
Was our starting equation x squared minus?
Yeah, this right here is the start. This is what they gave us. So if I make all my x's and y's opposite, it simplifies to the same thing.
They gave us a minus x, but
Because of minus, it wouldn't really matter. Oh yeah, you're right. It wouldn't really matter though. Well, this would turn into a minus, but it's the same thing. Since we didn't get to that one on the normal homework, I won't put that on the test. Number 6, given the graph of y equals blah 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 shown at the right, sketch the graph of each of the following. Oh boy, this is my favorite part. I actually do kind of like these a little bit. Oh wait, hold on. There we go. I don't want to waste paper. Okay. So basically on 6A, I'm going to go ahead and draw the original. That'll probably help us. Yikes. Probably doesn't need to be that big, does it? It goes up from -3, 2. Step down, over, down, over, way down. I think that's it. Yep. Okay. What's going to 1.16a, when you multiply everything by 2, what's that going to do to the graph? Right, it goes twice as tall. Another way of thinking of it is it's going to stretch vertically 2 times, but it's going to stretch away from the x-axis. So it's not like shifting up, it's like stretching out, kind of like zooming in. I don't think I can zoom in, kind of like that, but anyway, all these coordinates, so if this was at -3, 2, this point right here is now going to be at -3, 4. So that basically the y coordinates are doubling. At -2, 1 is going to go up to 2, -1, 1 is going to go up to 2. Where's 0 going to go? 0 times 2 is still 0. 0 times 2 is still 0. Then the y value jumps down to -2, or the function value jumps down to -2. So that times 2 is -4. So everything is twice as tall, twice as high, twice as low. All right, on B, what does the absolute value do to the graph? Absolute value makes negatives positive. So where this function was negative, it's going to become positive. I probably should start over. Okay, I'm not going to draw the whole thing, I guess. I'll just, so where it was positive, it's going to stay positive. Where it was 0, is anything going to happen at 0? No. The absolute value of 0 is still 0. But where it dropped below 0, like where it's at -2, that's going to jump up to +2. So it kind of ends like that, with the negative becoming a positive. Holy mackerel. All right. What is the negative on everything going to do to the graph? Girls, what's the negative going to do to the graph? Which way? Upside down. Yeah, vertical flip. Okay. Let's. Ty, what's the +2 directly on the x do to the graph?
Move everything up to.
No, that would be a +2 like out here. So that would be like, this would be an up 2, but if you put it directly on the x, left 2. So what was right here will be right there. Let's see, it started down here, I guess. Oh, I did something wrong, didn't I? It's not left 2. Oh, no, I did. That's right. Never mind. Thought I made a mistake once. Turned out I was wrong. I
said that in the other class when Will was in there. He's like, that's not possible. If you thought you made a mistake, then you did make a mistake. I was like, Will, that was a joke. The other day, this was like a couple weeks ago, Carson said some kind of pun. It was terrible, and I said, Carson, go to the office. And Will goes, that's your punishment.
He's the pun police.
The bad thing is, like a lot of the class started laughing, so, which that guarantees you're due for another 5 puns. Until people start complaining too much. Uno mas. What's the next one? Periodic functions. All right. Do you guys remember the 2 terms we had with periodic functions? The period and the amplitude. What's the period mean? Right. How long it goes in the x direction, how many units before it starts repeating itself. And the amplitude, this one was a little trickier. What's the amplitude mean?
Like either the top or the bottom to the middle.
Right. Okay, it's not the height exactly. You could do the height divided by 2. It's more like how far from the middle does it go up and down. Okay, so A is what is the period? So how far does it go before it starts repeating itself on number 7? I guess we don't need a graphic for this, do we? No. Yeah, so you could look at different points, like the tall hills go from -2 to 2. So that would be 4 units over. Yeah, anyway, or the low hill goes from 0 to 4. Anyways, 4 would be the period. What is the max and minimum values? So how high and how low does it go?
4 and 1.
4 and 1, yes. It goes up to 4, down to 1. Basically, it's kind of like the range question, but it's just 4, 1. What is the amplitude? So if it goes from 4 to 1, how tall is that graph? 3. So the amplitude would be half of that. So 3 divided by 2. So you could say 3 over 2 or 1.5 would be the amplitude. All right. Well, I was planning on working on this some tomorrow. We're getting pretty close to done. So I'll probably just start the test review tomorrow to make sure we have plenty of time, so I don't have to rush on Thursday. But we'll finish 9 and 10 tomorrow, I guess. Yeah, we're skipping 8.